So what are we going to learn in this course and why? In this course, we are going to study two formal languages. The first one is called TFL, and the second one is called FOL. TFL is the language of truth functional logic. Now, in TFL, we have some very basic symbols that help us to symbolize English sentences. The symbols in TFL include letters that represent entire sentences and the so-called Boolean connectives that allow us to construct more complex sentences out of the simple atomic sentences. And we are going to learn how to test TFL arguments for validity using truth tables. And we are going to learn how to construct proofs in a natural deduction proof system for arguments in TFL. The language FOL is the language of first-order logic. FOL is a more fine-grained language in comparison to TFL. So in FOL, we have symbols that represent not just entire sentences, but also elements of sentences. So in particular, in FOL, we have names for objects and predicates that stand for properties. And in addition to that, FOL also includes quantifiers and the identity sign. Quantifiers are words such as every or some that allow us to express quantities. And we are going to represent the quantifier every by means of this upside down A and the quantifier some by means of this reverse E. And then we are going to study the meaning of FOL sentences, or in other words, the FOL semantics, using interpretations. And we are again going to study a natural deduction proof system that is going to allow us to develop proofs of FOL arguments. And along the way, we are also going to touch upon some advanced topics, including expressive completeness and meta theory. So why are we studying this? Well, one reason may be that you're just interested in good reasoning and you want to understand what makes arguments good, and you want to hone your sensitivity for the quality and strengths of arguments. That is one good reason for studying logic. But logic also has many important applications. So one important application of logic is in philosophy. In fact, logic originates in philosophy, specifically in the philosophy of the ancient philosopher Aristotle, and it is traditionally considered a subdiscipline of philosophy. Now, valid arguments are critical in philosophical research. Philosophers want to develop valid arguments for philosophical viewpoints. And the formal tools of logic are useful for making intuitive and imprecise philosophical notions more precise. So, for example, logicians have developed tools for formalizing the philosophical concepts of possibility, necessity, time, composition and parted, moral obligation and permissibility, belief and knowledge. And finally, logic also applies to the semantics of natural language, and in virtue of that is useful in the philosophy of language and linguistic. So these are the most important applications of logic in philosophy. Logic also has many important applications in mathematics. Formal logic was developed in the quest for a foundations of mathematics in the early 19th century. And in mathematics, logic has two main important applications. For one, Logical systems provide precise foundational frameworks for mathematics, and this includes axiom systems, such as axiom systems for geometry, algebraic structures, such as groups, and set theory, such as the Zermelo-Fraenkel set theory with the axiom of choice. And then logic also helps in mathematics by adding precision to mathematics. So formal languages that logicians develop help mathematicians to make certain claims more precise. Formal structures developed by logicians can point to alternative theories or viewpoints and unveil gaps in proofs. And formal proof systems help to make proofs in mathematics more rigorous. So, for example, formal proof systems allow us to develop formal proofs which we then can mechanically check for accuracy and search particular lines in these proofs. So these are the most important applications of logic in mathematics. And finally, logic is also important for computer science. Computer science as a whole deals with lots of formal languages. And the kinds of languages that logicians develop are one good example of how to set up and use these formal languages. And for that reason, logical systems have many applications in computer science. So these applications include combinatorial logic circuits, database query languages, logic programming, knowledge representation, automated reasoning, formal specification and verification, for example, of programs or of hardware designs. And logic also has important applications in theoretical computer science, as in the theory of computational complexity and the semantics of programming languages. So these are some of the most important applications of logic in computer science. And so what that means is, if you're interested in studying any of these areas of research, philosophy, mathematics, or computer science, knowing more about logic is going to help you.